Right, the final formula for this week to do with differentiation is quotient rule. So the product rule was if you had two functions multiplied by each other, u times v. This one is if you have two functions divided by each other, so u divided by v. So on this one, it's very important that u is the numerator and v is the denominator. If you don't follow that, this will not work. But the formula is given in the formula book in your exam. So if we jump straight into an example, y equals 2x over x add 1. Follow a very similar pattern to before. Just make sure that you know which your u and your v is. Remember, u is the numerator, so the top, v is the bottom. If you differentiate them, you get 2 and 1 in this case. So dy by dx would get you u dash times v, so 2 lots of x plus 1, minus u, 2x times v dash 1, all over v squared, so x plus 1 squared. And this can simplify a little bit because we have 2x, take away another 2x, so we have nothing, no x's at least, and 2, so it's just 2 over x plus 1 squared. If it's straightforward like this, I would always simplify it. If it was a more complicated function like some of the ones I'm going to do in a second, if it doesn't say you have to simplify it, you don't have to. But usually they would say leave in whatever form. So, question 2, let's go for a little bit more complicated, not much, but x squared over 5x squared add 3. So u has to be the x squared and v has to be the 5x squared add 3. Differentiate both of them. And if we follow the formula that was given above, which I don't think you can quite see at the moment, but it's u dash times v minus uv dash. I'll write that again here just so you can see it, over v squared. So u dash 2x times by 5x squared add 3 minus uv dash, so x squared times 10x, all over v squared, so this thing squared. And I might simplify that a little bit because we have 2x times 5x squared is 10x cubed minus, coincidentally, 10x cubed. So on this one, 10x cubed, take away 10x cubed is nothing, and you're just left with 6x on the top. Right, a couple more. So the third one I'm going to try, x add 4 over 2x plus 3 to the 5. Again, I'm going to apologise for my handwriting because it's just got worse over this lockdown period. So u equals x add 4 and v equals 2x plus 3 to the 5. So you should hopefully see u differentiates nice and easily to 1. But v is a bit more complicated. This is a throwback to the chain rule from the day before yesterday. So multiply by the power and lower the power by 1, then multiply by the differential of this function, which is 2. So that is 10 lots of 2x add 3 to the 4. So if you differentiate, that means we've got to put it in our function again. So u dash 1 times v minus uv dash all over v squared. Now, if you do 2x plus 3 to the 5 and square it, should hopefully know from your index laws. If you square it, you multiply the powers, so that will get you to the 10. I'm not going to bother simplifying all of that, but you could do if you wanted. Right, and question 4. Y equals x squared add 5x add 3 over x squared minus 4. U would be, I'm already differentiating, U would be x squared add 5x add 3. V would be x squared minus 4. U dash would get you 2x add 5. And V dash would get you 2x. So then altogether, that leaves us with the quotient rule formula to fill in, which is U dash times V. So 2x add 5 times x squared minus 4 minus UV dash times 2x all over x squared minus 4 squared. Right, that's it for this one. Like I said, both of these could be simplified further, but at the moment I just want to make this a quick video going through how to actually apply the quotient rule. I'm not actually going through how to manipulate algebra. I'll set, like yesterday and the day before, we'll set you a few questions, and then later in the day, if you want to ask me for the answers, you can do, and I'll send them out. I'll send them out about 4 or 5 o'clock tonight. Okay? Good luck.